Welcome. Today is Saturday, the 20th of February 2016. My name is Chris Ellis and this is another Fullnode update. This is the Fullnode up and running. As you can see, we've got the latest version of Bitcoin QT up and running, which is version 12 or 0.12, and it's formally released about 2 days ago by the Vladimir van der Laan and the other developers of Bitcoin Core. And also I wanted to show you, I'm just going to mount the camera on a tripod, and I'm going to show you another thing that we've got up and running on the Fullnode, which is an advancement over the last one, which is we had IPFS, but now we've got something called IPFS Station. So I'm hoping this is going to work. npm start. It's running in Node.js. I've got Node.js 4 running on here. And the guys at IPFS were super helpful, and they've helped us to get this all up and running. So unlike how it was on the original Fullnode software that I sent out, this time it's actually running with a little graphical user interface, which we should hopefully see up and running in just a moment. Let me just close down the browser. And we have had some errors with it, like sometimes it crashes. The actual IPFS itself doesn't actually crash, it's just that the user interface crashes. So server started, uh-oh, it's live, I can't take it back now. What's going to happen? There it is. Okay, so in the bottom right hand corner, it's a little bit slow, but it comes up, and then up here we have eventually the user interface, or at least we should do, and then we've got this spewing out the log in real time. I might actually have to, oh no, we've got loads of errors. Okay, I will report that on their Git repo. So I'll reboot this and try to give you a demonstration, because it actually does look quite cool. But before I do, I'm going to hand over to the venerable Oliver Morris. Ollie, hi.
Hello. So we're gonna do the we're gonna do the send Bitcoin thing, the Bitcoin library of Peter Todd. Did you? Can I ask you something, Steve? Did you get a way? You know the RPC. Did you have to import that, or have you found another way?
No, the code you had the other day was outdated. If you do import bitcoin.rpc, it works with the Peter Todd library.
Does it? Oh. Okay, so I'm going to show you something, because with this send thing you had to get your account address, but if you don't actually, just say you're in here and you don't have you're not a GUI, you're just using PuTTY, you can run this command here, get account address, and then the name, mine's Ollie, and it'll give you your IP address there. Not your IP address, your Bitcoin address, because you would need that if you're sending it. Then as well, you could just write on here, you could just write Python. No, not Python. Go to the code, my file, and you could probably just type Python. You could type Python, then send.py. You wouldn't actually need to go into here. My balance is 0.8 of bitcoins, and then your address you want to send to. Oh, not that. Then you would get your address from here. Where is it? There. There we go. And then please enter the number of satoshis to send. If you just hit 1, it will send you an error because it's not enough. It's not enough that you have to send at least 1,000, isn't it, Steve? About 1,000. There's satoshis.
I think the dust level's at about 500, 600 satoshis.
Oh, okay. I only did ones, so we can just run that. The next
If
thing.
you only send a few satoshis, you need to be able to pay for another transaction at the next address. So it's best that you send more than enough satoshis to cover another transaction.
I'm going to do that. Okay, so ready for that. There we go, coins has been sent. And that's spelt wrong. I don't know. Okay, so now we're going to go, here we go, look, got a transaction here, but it's minus, because there's not enough. There's actually not enough still there. But I got a transaction now, I paid to myself. I actually paid it all to myself. I should have put another Bitcoin address in.
You can create more than one address if you want.
Yeah, I know, I had an example one there. So that's probably kind of that's kind of the only thing I was really going to talk about, really. Bitcoin. I'll show you the code first, actually, if you want me to write it. And in the last video, not last video that's on this channel, but the last video that I did with Chris was about was about how to install the our Bitcoin Peter Todd library and the other one, but I'm not sure if you even need the other one now. These do.
Do you need the other one, Steve?
No, no, you don't. The other one's outdated. It was Bitcoin RPC with no dot in it for the old one. And if you do Bitcoin.rpc, that's how it's formatted in Peter Todd's library.
Okay. So we haven't. Yeah. So what up here? The address equals the raw input. I explained everything actually. So import bitcoins on module. Then the bitcoin to select parameters. Set parameters. I think it is parameters. I think. I'm not sure. Yeah. Then the main net. It could be testnet, but my testnet isn't running at the moment. Then import the Bitcoin RPC. I should actually worked out what RPC stands for doing this, but okay.
Remote procedure call, isn't it?
Pardon? The next thing is import the Bitcoin.wallet.
It stands for remote procedure call, RPC.
Okay. Then my proxy is a variable that could equal to anything. Then it has to equal to that could equal to anything is what I meant. This has to equal to Bitcoin.rpc.proxy. Then the balance is I called it bow just for balance. Actually, this is Steve. Steve wrote some of this code, but I helped him out with some stuff, didn't I, Steve? At the bottom, some of it. You wrote a lot of this.
Yeah, you helped.
Then we have the print, the balance of that. So it comes up with your balance is, and then you address equals to raw input. The raw input on the screen of please enter the Bitcoin address to send to. So what you want to send it to. Then if the length of the Bitcoin address, of the address of that variable address there equals to 0, then print no address supplied. Have a nice day. Because if you don't type anything, it will just put that. I might edit this and put and not this video, but edit this code and put else if there instead of else, and put if the Bitcoin address equals to address and it equals to 25 to 36. Is it 24 or 25 to 36? How what the length can be of a Bitcoin address.
Oh, what, to make sure that they put in the correct address, you mean?
Yeah.
Yeah, I mean, you can look in the pro tip code to see the regular expression. You can use regular expressions to work out whether or not it's the correct length.
Yeah, you could.
And there's also a Bitcoin RPC verify address call you can use to check if an address is a valid address.
Is it? That's cool.
That's even better, yeah.
Then else, that's basically it. Else, then if Satoshis, which no variable, equals to raw input, please enter the number of Satoshis to send. And if the length of the Satoshis equals to 0, then we cannot send 0 Satoshis. Closing program. I had put this part. It meant, what else was there? I think it was, I don't know what else. It's something else there before. And then I actually took the code and did some stuff with it. Then else, my proxy, which is this bit here, of the beginning part, to send to address, then you put these two bits in here, which is the address, so please enter just to, and the Satoshi, which is how many you want to send. Then print your coins have been sent, then exit.
Great.
Yay.
Sounds good. All right, what else is new? Steve, got anything to demonstrate, show us, talk about?
Yeah, absolutely. I've got some new Peter Todd Python code. Let me share the screen with you. So we've got some code I've been preparing here using the Peter Todd Bitcoin library. So we've got the import Bitcoin. We're running on testnet. We import Bitcoin RPC and create a proxy object. And then we create.
Is there any way you can make that text bigger on your screen? Is that under format or something? Or
is that any better? It's full screen. It's
okay, well, it'll do for now, but yeah, if there's an easy way of making the text bigger, then
I'll do it. Let me see if I can zoom. No.
It might be under edit or format or something.
Yeah, I think I know.
Is that better?
Yeah, that's better, yeah.
So we're importing the Bitcoin Peter Todd library, and then we select the parameter for testnet. We then create an RPC object, and we use that to query the Bitcoin blockchain, and we get the block count. From using the block count, we can then get the block hash, and then with the block hash, we can get the block information. Once we've then got the block information, we can convert it into bytes using the serialize command. I'm not too sure what this does just yet. I need to investigate that some more. But once we've got the block information, we can then access information from within the block. So we've got a few print statements here. We print the block number in this line here. We then print the difficulty of the block. We've got the version of the block, the number of bits, the nonce, the time, and then the VTX is the list of transactions. So if we then, here we can run a Python and run this script. You'll see we get the following output. So at the top, here we've got the block number, we've got the difficulty. Remember it's testnet, so it's a low difficulty. The block number is version 4, the number of bits, the nonce, and the time. And then the VTX, we've got the list of transactions here. You can see they're in a compressed format, which I don't understand at the moment, but you can see some of the script information here. You've got op hash 160 op equal, which is the signature checking for Bitcoin transactions, and you can pull out other information. But it's a little bit messy, and you also get the Merkle tree information, and it's quite difficult at the moment for me to understand all of what this is. You've got the raw block data here as well. So what I've also been working along is another script, which is a block notify script, which we've got here. So this script will run, and we're going to query the Bitcoin block as we get it using the Bitcoin RPC directly. And this time we're able to extract some more information in a readily easy to be readable format. So if we look at our Bitcoin conf text file, you'll see here we have a line for block notify. So you can see we're running a Python script each time we find a block, and we're going to pass to that block the block hash here. Then that notify script outputs to a text file called test.txt, and you can see at the moment it's collecting a list of block hashes and the respective transaction hash ID numbers for each block. So there's been blocks here collecting up. There's 1 or 2 transactions per block. You can see this block had 2 transactions of 21. So we're slowly being able to unpick the blocks that as they're appearing on the blockchain.
Steve, on the
Sure.
last script, I think it was notify.py. I saw the open. You open that text. Did you open that text file, and then you would read
Yes.
it? You did.
Yeah. So in the notify. Oh, I'm trying to click on the wrong screen. So in the notify text here, we open the text file, as you can see, just at the bottom. Let me scroll a little. So we open the text file, read the contents of the text file, and close the text file. And then with the text file, we're going to output the block hash here. This is the block hash. It's my data, and number 1 is an array of data that we receive from the system argument. Let me scroll up and show you that at the top. You've got the import sys here, and then my data, we're grabbing the system arguments. The first argument that's passed is the name of the script. The second is the hash data from Bitcoin. So we've referenced the second variable using the number 1. Then we output a new line, and then we loop through the number of transactions. If there are any transactions, we loop through them and output them to the text file as well. And then we output a new line just so it's nice and easy to read for us humans. And then we quit the script. So the result of that script is then the test.txt file, which is this one here. No, this one here. So you can see you get the block hash and the transaction information. So you can see this block had 2 transactions, this block 2, this block only had 1, this block only had 1, and so on. So it's useful. We've been able to start to collect up information from the blockchain as and when it becomes available. So,
and the idea here is, Steve, that you're trying to look for specific, eventually you're going to be looking for specific blocks with information regarding the open provenance protocol that you're working on. Is that right?
Yes, absolutely. What we've got to do is to look at the block, and for each block there's a number of transactions, and we've got to look at each transaction, and then we'll check through the transaction, find if there's any op return information, Then if there's any op return information, we'll check to see if it's open provenance related, and if so, we'll then work with it a little bit more. So it's going to take a little while, but we're building it up step by step, and we'll publish these scripts so that you can work along and use them to do your own things as well.
That sounds really fantastic. That's great. Well, I'll show you the IPFS working. I've just rebooted it now. It does basically work. Now, they are working at the moment on a new version of IPFS that is coming out in quotes soon, as we all know, an in-joke within the crypto community, soon, TM. So I'm going into the station folder, this IPFS station, and I'm going to run npm start. So let me just run that now. It does take a little while. It's written in JavaScript, Node.js, so that's a server-side JavaScript scripting language. I've also got it running on my hipster machine as well, on my Mac. And let me just see if I can change the contrast settings on here. There we go. Take the brightness down a little bit. So yeah, because it's on a Raspberry Pi, it's not super fast, but it does basically work. You can run IPFS headlessly without this, of course, and it will still be just as good. Just requires a bit more technical know-how in order to get that working. And the Fullnode, of course, will come as standard like it did last time with the Iceweasel browser and CryptoCat and all those other things. You've also got, on the new version of Jessie, we've also got Office, LibreOffice, Calc, Math, Writer, so you've got like word processing and stuff down here. I don't know if you can see that. Let me take the brightness down a bit more. Can't really see that very well, but yeah, let's hope this loads up. Info starting tray, there's the down the bottom and the right here. Let's just go to, let me just try. Yeah, does that work? Yeah, that's much better. So yeah, on the menu on the left here, you've got a lot more things to play around with. There it is. So top right corner, you can see like how many peers are connected on the IPFS network. Let's take the exposure down even more. There we go. You can see that. And you can go to console, and then a console window loads up, and then that will show us like a public key. It will allow us to add files, so that's your IPFS public key there. If you want to add files, you can simply select a file from your computer and start hosting it on IPFS. I don't know that it will work. No, it might need to do this via the browser because I was having problems with that before. So we'll go browser, see if it works. So that's loading up localhost 127.0.1. That's your local host. So you're now the server, not Google. Oh, there it is. So we've got a file, and that is the error message I was getting that I uploaded to GitHub. So it did actually work, just didn't give us the output. So yeah, if you're on IPFS right now and you pause this screen and you type in this big long number down here, you will be able to download that file from this Fullnode. And so that is IPFS. It's a decentralized networking file system. And I also want to, as well, draw your attention to a blog post that was written by a friend of mine the other day. Did a particularly good job, I felt. And this is called The Permanent Web. It's part 1, History, IPFS, and Ethereum. And it's a friend of mine who's a historian, and she's writing this incredible blog called Histories of Things to Come. And we had had some private discussions, and I had directed her towards IPFS, and I said, look, I think this is very interesting. It's something that I've intuited in previous years. Have perhaps had I had the same idea. I think a lot of people have had similar ideas going back over the last 30 to 40 years about a content addressable hypermedia network like the internet is. So content addressable means you're not finding an IP address that's locked by a domain name server that's like centralized, you know, with institutions like ICANN and the US government and stuff like that. It basically means that instead of going to like historiesofthingstoCome.blogspot.co.uk, you're going to address content by its hash, by its cryptographic hash. So you're addressing it by its content. And I put it to my colleague here that actually this presented a new form of history, because what's going to happen is children are going to be born into a world where this is normal. If you just think for a moment about how much of the technology that's been around now for more than 15, 16 years, that means teenagers today are being born into a world where they've already got mobile phones are normal, the internet is normal. We've got one right on air with us. We've got Ollie, you know. He's born into a world where the internet is simply normal, right? It's just the normal thing. And what you have to understand about technology is that when we're born into a world, we're born into a world without choice. Nobody chooses to be born, nobody chooses the time or the era that they're born into. And so anything that's already existing when you're alive seems perfectly normal and natural to you. Now we've got to think about what this means. When you start to use IPFS and you embed the hashes, the links of IPFS, which are cryptographic hashes, into the Bitcoin blockchain. Bitcoin is a superlinear structure, right? It just goes in one direction. It's an append-only distributed database. You can't roll it back. But IPFS has this beautiful quality where it can go, it's omnidirectional. It uses the same technology with Merkle trees and so on, very similar to Git. It actually allows the branching off of various documents. But every time you branch, it's not without consequence. When you branch, you create a new hash and you create a new tree. You create a new branch on that tree. And what happens is that people, when they download your content from your computer, they can choose to pin that content or host it. That's another way of saying it. The verb that IPFS are using is pinning, but pinning is the same as hosting. So it's not like at the moment where you've got these big servers up in the cloud and like companies like Apple and people like this are hosting all this content on the iCloud servers, which gives them a liability, because when the feds show up and knock on the door and say, hey, you know, give us the keys, give us the master key, let us break in just this one time, you know, just let us in this one time. And what happens is that Apple now have a liability on their hands. They're persisting data on their computers that is involved in a criminal investigation, because they cannot control what their users do when they ship out their fancy hipster devices. It's the same with Toyota. When Toyota ship cars, they can't stop ISIS from using Toyota cars to drive around in. So it's no good, you know, the feds turning up at Toyota factory saying, look, could you just like break the car or like give us some remote access to cars so that if an IPFS person is driving, beg your pardon, if an ISIS person is driving one of our cars, we can like, you know, intercept it and like steer it and drive it and put the brakes on and stuff like that. I mean, this would be horrendous. It's just a recipe for totalitarianism. So these kinds of structures like IPFS, like I've just demonstrated to you, bring about a kind of self-sovereignty, a self-asserted identity of the individual, where everything is encrypted end to end. And one of the things that I think my colleague Histories of Things to Come does really well is she starts it off with Orwell, and she talks about how, you know, history has to be stable in order to be functional, because if it's not and people are able to change history on a whim according to their wishes, then we get tyranny. And that's something that, you know, Orwell tried to get across in 1984 with doublespeak and so on, anti-historical tyranny. The future, quoting, the future or to the past, to a time when thought is free, when men are different from one another and do not live alone, to a time when truth exists and what is done cannot be undone. And I think that that's very well put, and that's a line from Winston Smith, the protagonist, in 1984. And yeah, and she talks a little bit about Ethereum. It's a very, very rich post. It's very good to read. It will take you time to read. It's very dense, very academic, but it's very, it rolls off the tongue. Each paragraph leads you into the next. You want to keep reading it. Also, a really good video here, an interview with Vitalik, who's the founder of Ethereum, and I particularly would draw your attention to 30 minutes into the video, 20 to 30 minutes in, where he starts to talk about the real nitty-gritty, the nuts and bolts of Ethereum, and also showing this, again, this was Paige Peterson, and I gave her a shout out in last night's show. You know, this is this sort of nuanced structure where you can see client to server and peer-to-peer, and you've got centralized to more decentralized. And so this is much more nuanced way of looking at the new sort of mesh networking world that we're going from, that we're coming into, that we're coming from a server-rich paradigm into a client-rich paradigm. And actually, one of the interesting things that Vitalik actually says in that video is that Ethereum doesn't have UTXOs like Bitcoin does, doesn't have unspent outputs. It basically contains balances. The blockchain, the Bitcoin's blockchain, doesn't contain any balance information. It simply contains a record of asset reassignment from key to key. Right, so I assign the tokens from my public key over to Ollie's public key, and then some witness, a miner on the network, will witness that transaction, and then we'll timestamp it into a blockchain. Whereas Ethereum, it's more about declaring a balance has changed from person A to person B, and so they therefore have to store less information, less data on their blockchain than Bitcoin does, and that's just an architectural difference. So at 30 minutes into that interview, on that blog post, I will put the link down in here. I've been tweeting it out. If you check me out on at Mr. Chris Ellis, I have tweeted it out. So that's really, that's the update for today. These full nodes should be ready to go out in the next sort of 2 to 3 weeks. I've just basically got to duplicate all the disks. I've obviously got to do a lot of testing. But I'm going to try and include as much good stuff on these nodes as I can. I'm waiting for the IPFS team to tell me when version 4 is out so that we can iron out some of the stability issues with their software. But if they're able to get that out, you know, sometime in March, then I'm up for shipping these full nodes in March, and you can all look forward to that. Anything else? Any questions from the troll box, Johnny?
No.
Nope. Okay. All right then. Anything else, Ollie, Steve?
No, that's it from me for now. Thank you. See you soon.
Great. Well, thanks a lot for coming on. And Ollie?
Cheers.
You all good?
Yeah, I'm good.
Good, good. Well, nice short show then. That's very, very unlike us. I will keep on doing these updates as frequently as I feel necessary. I'm going to continue to clone. Also, just to show you, this is the super node, this other node that I'm working on, which has got the, well, that's got Dash on it, but then also I'm working in the same infrastructure. I'm also building the BitCore software as well. So I'm looking at Dash, I'm looking at the BitPay's BitCore API, and also eventually, when I get around to it, I've got a lot to do. I also want to look at Ethereum as well and putting an Ethereum Fullnode out there. So thank you very much for joining us, and we will see you next time whenever we feel like it. Might even be later on tonight. Who knows? Very unpredictable.
Bye.
Stay safe. Bye-bye.